So, very good evening to all of you joining us here today for the webinar on repair and rehabilitation. Thank you very much for joining us today evening. We at SS BuildChem, we are very proud to bring this webinar to you in association with our exclusive partners for injection systems, TPH Bausysteme, who are one of the worldwide leaders in injection technology, as well as with SS BuildChem Private Limited. Means we are the ones who are actually presenting, and along with IITD, Institute for International Talent Development, which is a organization specializing in training, especially in the field of material technology. I would also take this opportunity to wish you all a very happy Baisakhi today. We are still, as of today, still in the lockdown mode. So hopefully, this adds a little bit more interest to our technical discussions and to sharpening our knowledge skills over time. And with that, and also, what I'd like to say is I'd like to thank Y, that is Waterproofers Association of India, especially Mr. Sandeep Chaudhary, Mr. Kunjan Popat, and Dikshit Bajaj for pulling out all stops in trying to put this program together. So with that, I believe we can get started with the program for today. We already have somewhere almost close to about 300 people online with us today, and just hoping more would join as we progress through the evening. So before we start up today, some announcements. I would request all of you to please make the settings onto your app as following. Like, please ensure that your microphone is put on mute, which I think it already is. But I would also request you all to put your cameras to the off mode, just so that it doesn't crowd the screen, and other people can kind of view the content very clearly. In case you have it, you can also go to the More tab. There you will see something called a side-by-side view. I think you can put that on. It will make it much more easier. So you can view the presentation on one side of your screen, and then you can view the participants or the speaker on the other side of the screen. Okay. Okay. Once again, I request you to put your speakers on mute, and also to stop your videos. So just so that the display overall becomes much easier for the other participants as well. And another thing, I'll just keep this slide on for a few seconds longer. In case of your questions, please send in a quick WhatsApp message to Mr. Kunjan Popat. This is his number that is flashing on the screen. So any questions during the session or something, you can immediately just type in a message to Mr. Kunjan. His phone number is also on the invite that we sent you over, and he can then forward it to me at the end of the session. Great. So as we progress into the main topic of today, today we'll be talking much more about concrete repair and protection. And what we'll be discussing today is much more on the concepts and solutions. Okay, I hope the volume is much better now. Perfect. So yeah, like I was saying, in terms of okay, once you're also sending the questions across, please also mention your name along with your question, so that it becomes easier for us to answer and to refer to you on this one. And we'll also try to put the meeting view on, so then we can actually see the person who's asking the question at a later stage. Okay, so continuing with our topic for today, what we'll be talking about is concrete repair and protection, and what we'll be looking at is much more at the field of repair as a concept, I would say, much rather than much rather than simple like what material to use. Of course, we'll talk about the materials and the properties needed, but what we'll be talking about it is what is repair and protection as a concept. So, once just to briefly introduce myself, so I'm Sunny Surlakar. I'm the head of technical services at SS BuildChem Private Limited, and as you can see, we are also the TPH and IITD. So we just did the intro at the beginning of the session. I'll not go much into it. Uh, Very brief bit to introduce our company have been SS BuildChem has been around since 1994. It's a technology-driven company which started off more as a consultancy firm, then went into R&D, and from there are now into manufacturing. So what makes us different from the others is the knowledge or the technical knowledge of how to do things right, and also our focus on training and development is something that brings us much closer to the people who work with us, and the focus is always on doing things once and doing things right. So what we have today, and like a main focus today, is offering a complete range of construction chemicals, right from admixtures, side products, waterproofing, tiling systems, some sealers and cleaners, repair systems, protection, and some very special systems for heritage monuments as well. So, for all your technology needs, we can be your knowledge partners, and get in touch with us or stay in touch with us. So, once we start off the topic as a whole, the whole story starts off with concrete. So once we talk about concrete, it's the most popular building material, and then concrete and steel together make up RCC, which is, I would say, today the building block of almost every major structure that we see. So be it big buildings, be it infrastructure like bridges or dams or water tanks. I mean, you name it. So, and in all these places, we find that after, due to maybe age, due to due to construction problems, due to heavy loadings, we'll just talk about that over the next few slides. Each of these structures is prone to deterioration, and basically, it is because of the deterioration that the entire need for the repair industry or the repair concept came about. So what we're going to talk about today is not particularly about, say, one, maybe a building or only a bridge or only a water tank or a dam or something like that. But what we're talking about is addressing concrete as a whole. So once we do that, using the concepts that we go through today, we should be pretty much able to I would say, repair and rehabilitate any structure that we are looking towards as of today. Okay. So why does this happen? Like when we see the chief cause of corrosion or the chief cause of deterioration, it basically comes out of environmental attack. So a lot of people talk about things like, okay, the Taj Mahal was built say so many years ago, or the Pantheon in Rome was built say so many thousands of years ago, and they still stand. Then why not new buildings? I would also say that in the past, like from the industrial age onwards, the pollution has come up or gone up pretty drastically. So it is all the time things like carbon dioxide, carbon monoxide, even water, SOx, NOx. There's so many gases, so many industries, vehicular pollution. So all this pollution is directly trying to attack any new structure that we build. So yes, those structures, the older structures, lasted for a very long time, from the beginning of time or from the beginning of when they were built to now. But now, as the industrial age is progressing, there are problems relating the durability of these structures as well. So now, in a nutshell, if we kind of think about what causes the deterioration, we would find that very easily. It is basically, say, this is your concrete, and these are the kind of capillaries or the ingress paths for a lot of the materials. So it is carbon dioxide, chlorides, and water that will primarily cause your deterioration of your RCC structure as a whole. Basically, these materials, they get access to your reinforcement through the cover. Like in case your cover is damaged or not functioning properly, these things go down. What they do is essentially change the pH of your concrete. So concrete goes from a very alkaline pH to almost like an acidic pH somewhere over here. and that basically starts off with the problems of the deterioration in concrete. Of course, I'm not going much into the depths of this. I mean, a lot of you are already experts in the line of waterproofing, as well as there are many consultants joining us here today who again know and work a lot in this field. So I'm not going into the nitty gritty science of these things. So if you look at it in a very simplistic manner, we would say the key to preventing corrosion is simply to isolate your reinforcement. Okay, so either by improvement of the cover region, or by repairing, or by rehabilitating, or providing a protection to the concrete in the cover zone, we need to isolate the reinforcements from chloride, from your other gases, that is carbon dioxide, SOx, NOx, and water. So once these three elements are kept away from your reinforcement, okay, very simply the process of corrosion stops. So that means even if you're thinking about protective coatings, if you do it right at the beginning of the life of the structure, we can actually see that that increases the life of the structure quite tremendously and increases the durability quite tremendously for the times to come. So if you put a very simplistic view on the causes of RCC deterioration, you can see that they can happen either before, during construction, or after construction. So before or during construction, it may be due to design errors, like maybe say joint spacings are not calculated, or load calculations are not done properly. But this rarely happens. More so, the causes of deterioration originate in the mixed design errors or in poor workmanship. So things like poor aggregate grading, using very high water cement ratios. We talked a lot about that in a waterproofing webinar as well. And the second part comes, and this is where it needs much more improvement. That would be poor workmanship. So that means adding excess water to concrete, not compacting it properly, not curing it properly, not working properly on the reinforcement zones or the cover zones. Like that is where the problem of deterioration actually begins. And also the other part, say if you have done all the first part of it correctly, then comes the problem about in-service. So when we talk about in-service issues, then there are problems like static or dynamic overloading. That means that there is a mechanical stress on your structure, overloading, lot more dead weights, maybe say something like a collision, explosion, things like that. Thermal variations, these are the primary way of causing cracks, and cracks are the beginning, or they're both the beginning as well as indication of a deterioration process. So everything starts off from a crack. Then there might also be excess chemical loads onto your structure, which can be either all these gases, COX, NOx, it can be water, then acid, salt, alkalis, especially underground structures and all. They are exposed to a wide variety of these kind of aggressive chemical materials. And also the last but not least are biological factors that deteriorate. Simple things like growth of fungus on your concrete, plants in your structure, like they are all both indications as well as causes of the structure starting to go bad. So what can you do in cases like this? Once you say, okay, we have started to have a problem. So from there, the first thing that you can do in the repair, means even when you're evaluating a structure, the first step is do nothing. Okay, that's maybe, I mean, there might be something that you can do, you cannot do, but okay, that is one option that you have, that you do nothing. The second option you have would be to reanalyze. So you say, okay, maybe this building has got some heavy loads, or maybe it's running some machinery somewhere. So if we can reanalyze the structure and change the use for it. So that might be another option that you can look at, for example. So you reanalyze the structure. The third one is you downgrade the structure. For example, if a bridge has lost its load carrying capacity, then you say, okay, on this bridge we let only cars go, for example. So you can downgrade your structure like that. Then the next part comes, which is important. So you have decided that something that you can do is you have to take some action. So some action means you can either improve the structure. So that's where your repair and rehabilitation comes through. Strengthen the structure. That's where your retrofitting comes through, I would say. And the third option is, again, is you can reconstruct parts of the structure, or repurpose parts of the structure. And the last, if there is no option available, maybe say it's not financially viable to take up this particular point. So in that case, you have to think about demolishing the structure as a whole. So uh, in most cases, the logical step of action would be that concrete needs to be repaired. And again, here we have to understand both, like what is causing it, and in that the materials are the key. Okay. So anytime you are taking up a rehabilitation project or repair project, then you have to take care of three things simultaneously. It's not one or the other. It has to be taken simultaneously. So things like a concrete condition, like what are the defects, damage, what's causing it, the deterioration part of it. Then what are the aspects of the structure itself? Means what is the end use going to be? What are you planning to do with it after your repairs and rehabilitation? Are there any constraints to using it? So everything relating to the structure is the second part of it, and the last part of it is the repair program. So like what members do you require? Do you repair? What is the action plan that you follow? What is the specification that you follow? Okay, and what kind of planning, materials, what are all those things? So once you bring in all these different points, then that constitutes your repair program in general. So now the criteria for material selection, like normally when we talk about repair, oftentimes the discussion first jumps into a material. Okay, so most people talk about, okay, my repair, okay, I'll use a polymer for my repair, okay, I'll use so and so for my repair, or do you have CFRP to repair? But I would say this is where the criteria for material selection is where basically all our structural engineers or our consultants, they come through, because they are the ones who can actually put performance criteria rather than prescriptive criteria. Because see, they understand how the structure behaves. For example, even if they need a mortar to, or they need a mortar to fix or to repair a particular element, then it is like they have to specify the performance criteria of the entire material. That means they have to say, okay, I want this kind of compressive strength, I want this kind of flexural strength to it, I want this kind of bond strength, rather than saying that you make a mortar which has got, say, one part cement, three part sand, and something else. So that might be one of the means. I don't think that's the right method for each and every step of repair. So I think somewhere the performance criteria has to start getting into this. So this is another thing where our consultant friends really have to come together to guide and to drive the repair process, and that is in terms of diagnosis and testing. So, like all of you, there are many of you who are in the field of doing or executing the repairs, and then there are other consultants who are working in the field of specifying and designing the repair system. So, I would say to both the parties involved, anytime a repair system comes to you, I think the first and the most important part of it is diagnosis, and this diagnosis can come through only through proper testing. It is like going to a doctor. Okay, you go to a doctor, and the first thing the doctor asks you to do is get some tests, and based on the test that he will make a diagnosis. So even basic things like a phenolphthalein test, crack movement, then you have say maybe test like a pull off test for strength. The one here on the left hand corner is for for getting small samples to test the chloride profile and chemical makeup of the concrete. Then you've got other non-destructive testing based on say impact echo, or it is based on UPV and so on. And then you have a Schmidt's hammer, something that can just tell you whether the surface is good or not. So this kind of testing is very important in the whole diagnosis part of it. See, another thing, once you're going for the testing part of it, is you have to observe the reinforcement corrosion. Like this will tell you a lot whether your problem is actually structural or non-structural. For example, many times if you see a generalized corrosion in your steel, most probably it is because of carbonation. So that means you'll see generally that your reinforcement will show general rusting around all the sides. Then, in case it is localized corrosion, in that case it is much more dangerous, because one is it might be due to chlorides, and chlorides cause severe pitting, which means loss in the rebar section. It can sometimes also be due to if a concrete structure is constantly under stress, under some creep. In that case, sometimes also you get stress corrosion in your steel, and you begin to see small cracks in your reinforcement. So a lot of times this kind of observation will also tell you a lot about what's actually happening to your structure. Okay, so you have to kind of take a look and establish the cause of damage, whether the cause of the damage is structural in nature or it is non-structural in nature. For example, if it is structural in nature, that means it is related to excess loads, maybe say chemical loading or mechanical loading or thermal loading. So it is because of those kind of things. And non-structural means it is simply because of durability based aspects. So the non-structural causes are much more easier to repair, because in most cases you just do a basic repair as well as then put a protective coat on top of it that will solve your problem. Structural ones are slightly more tricky, because you need a structural engineer to actually understand what is the load redistribution across your structure, and then he can actually tell you that where in which elements what kind of repair is to be done, whether a jacketing is needed to be done, is only a injection system would do, only concrete replacement will do, or you need to do CFRP for retrofitting and so on. So basically it is the cause that will determine the methodology of your repairs. And although the principles of repairs are pretty finite, so the principles of repair would almost be common for both repair as well as non, or also the kind of methods and materials you would use is would remain common more or less. So that is not the problem, but finding and treating the cause is the most important part, or the most important way of repairing a structure for proper durability. So that is where one of these codes come in. And this particular code is EN1504. So this is one of, I would say, the world's first proper coded provision, and it includes a definition, requirements, quality control, and evaluation of conformity for repair systems. So basically, it regulates the products and systems for the protection and repair of any types of RCC structures. So again, this particular standard talks much less about what type of or what structure you're going for, but it talks about concrete or RCC as a whole, and then it gives you certain principles to repair them to repair those particular RCC structures. So the information is very useful as a summary manual for planners, applicators, manufacturers, official bodies and test institutes, so on. So it gives them it's kind of a good specification guide for them. So when we talk about the principles of repair, so EN 1504 actually breaks it into two particular broad areas. The first one is concrete defect remediation. So that means these six principles are targeted only to remedy concrete defects. So basically, what it will talk about is to repair this, you can look at protect the concrete structure, again ingress of substances, again ingress of moisture. Then the third principle is concrete replacement itself, replacement or restoration. Then there is structural strengthening, then improving the physical resistance to damage and improving the chemical resistance to damage. So if you actually see the methodologies that are involved in that are more or less similar to what we already kind of do for repair. So it can be something as simple as just putting impregnation or coatings or protective coatings on top of it. Then you've got, say, applying your mortar by hand, recasting with concrete, recasting with micro concrete, or replacing the element. Then under structural strengthening, you have your CFRP, CFRM, installing anchor bars, adding or replacing reinforcing steel, and also most importantly, filling cracks and voids, injection grouting. So all these things we already kind of use for repair strategies. And what EN 1504 does is simply formalizes the relation, like in under what condition you will use what kind of methodology. And the second part that EN 1504 gets into is preventing reinforcement corrosion. So here there are five different principles that they talk about. So the first one is restoring the passivity of the reinforcement. So again, the first two principles, like 7 and 8, are based more on just providing protective coatings. Even cathodic control is pretty much similar. Principle 10, cathodic protection, is much more application of electrochemical methods like electrochemical extraction, salt removal, and so on, applying electric potential. And then controlling anodic areas is again by actually coating the reinforcement itself, your active coatings or barrier coatings for reinforcement, or using corrosion inhibitors in concrete. So you would actually see that the materials and the techniques that we use or have been using have been we have been using them for quite some time. but it's only that there has to be a formal way in which to decide what to do when. So that is why we say repair is an art if you know the science behind it. So the materials remain the same, the methodologies remain the same, but the art form comes in judging. Okay, what methodology will remedy what kind of cause, and what kind of effect it's going to have in the future. So the general sequence of repair, if we take again, it remains more or less the same. So you start off with the first step, that is diagnosis. You basically figure out what the problem actually is. So following that, you get to surface preparation so that your substrate can receive the repair materials pretty well. You have your corrosion removal. Following that, you have your corrosion protection. Then you have your bond coats, application of your bond coats, replacing your concrete, basically concrete replacement system. This might be your mortars or micro concretes or whatever things along those lines. Then you have a concrete cosmetic fairing coat, just to give a even kind of surface for your protective coating systems. And last but not least, once the repair is done, you have to protect your structure, because if you do all the very difficult steps of repair and you leave your structure unprotected, then your repair cycle is just going to repeat maybe within the coming year. So a failure of repairs becomes a big problem, and it can only be remedied by protecting our structure properly. So now again, if you take all those different steps that we just saw, what it would be coming into is mostly basically our injection systems, which can protect both against ingress of substances as well as structural strengthening. Then comes your after the surface preparation comes your corrosion protection systems. So this also helps in means it meets a lot of principles according to EN 1504. Then comes your step on bond coat, PCC, that spray polymer modified mortars, micro concretes, and so on. And followed last but not least by impregnations and coating. We'll also talk very, very briefly about strengthening methods that are CFRP and FRCM. These are some new CFRP has been used in quite some time. FRCM is a technology that is coming up in for different kind of structures. We'll just take a quick look into that as well. So if we start off with the first part, like the once we see that there's a problem, the crack basically forms the beginning of the problem. So it is both, like I said, it's an indication as well as it's an indication as well as a sign that something has gone wrong. So now cracks, you can see many different types throughout your design. You can have longitudinal cracks, you can have cracks due to frost damage, freeze thaw, like over say maybe shear cracks like this, maybe incorrect joints done something like this, maybe it is simple surface grazing due to shrinkage, longitudinal cracks. There are a lot of things. So the thing about cracks is some of them can be structural in nature, and some of them can be related to the durability of the structure. So it is up to us to find out the cause, what is causing the cracks. Of course, they can be remedied by pretty much the same kind of injection materials if you are basically looking at it. So once we talk about the different material types, so you have epoxies, you've got polyurethanes, you've got cements, you've got microfine cements. Then today you've got acrylic gels and also PUR foams. But if you basically see all the things to the right on the right hand side of the diagram, that means the microfine cement suspension, cement slurry, polyurethanes, and epoxies. And these are the ones that are normally tougher. That means they have both a very high tensile strength, a very high compressive strength, and extremely high bonding strength. So these are the ones. That are mostly used in your repair methodologies, as opposed to other different, as opposed to the other two types of injection systems. And the selection of the injection material depends pretty much on your crack width. For example, if your crack width is maybe say 0 to about 0.1, 0.2, 0.3 mm, then the only thing that can go inside would be a low viscosity EP or a PU or an acrylic gel. In this kind of cases, you can't go in with cement. Like if your crack widths are maybe somewhere say around 0.25, then you can start thinking about ultrafine cements. But only if your crack widths are more than say 0.8, 0.8, 0.9. So in that case, you can start looking at cement grouting as an option. So now, if you see again, the injection material selection is based on a variety of factors, like whether it's a surface crack or a deep crack. But if we take, when we talk about repair and rehabilitation, what we're looking to do is transfer loads. That means you have your crack face and you want to transfer the load from one face of the crack to the other side. So in that case, the best two options that you can follow would be using a hydraulic or a cement injection system, or an epoxy injection system. There are today certain PUs are also available with us, which we call as structural PUs. They also reach compressive strengths of almost 70. So in case your voids are a little bit wet, if they are damp, also the basic epoxy or cement can run. But if it's a bit wet, then you can also use those kind of structural PUs to seal those kind of cracks. So now, once we talk about these kind of materials, then they also need modern injection machines. Like this, for example, is a membrane pump, more for injection grouting with cement. Then you have your 1K pump for epoxies and basic PUs. And for the advanced fast reacting fillers, you also have your 2K pumps. So you need these kind of pumps. This is a very typical setup that normally happens. So you have your containers, you have your pump, maybe a data logger, and from here it is pumped into your structure. So along with pumps, you also need the right packer for the right type of job. Like if you're talking mostly crack remediation, then mostly we are using these kind of steel packers along with surface packers if they're, if the cracks are very close to the surface. But I would say talk more to us on how to select it. For example, if you're looking at only at cement injection, we can use something like this, like we call them hammer packers, or you simply just knock in these packers. Then these are the steel packers that I was talking about. These are most commonly used. And if your say cracks are along the surface and not going very deep, then you can use a simple adhesive packer like this. So modern materials, modern machinery, and modern accessories are what you need to do your job in the right way. So now this is another parameter which you have to understand very well. For example, we can think about repairing two kind of structures, that is masonry structures or concrete structures. So we can say the average masonry has got a strength of only about 8 to 10 MPa, somewhere thereabouts. We can say that the average concrete is somewhere around 40-45 MPa. So in this case, any kind of injection system that we are selecting has to also fit into these kind of values. So which is why for concrete more you can use both the cement based materials, you can use the PU or the epoxy materials you can use, because they really allow the transfer of load across the cracks. But if you are trying to treat a masonry structure, then it is better to use a very low strength material for that. So of course, there are a lot of solutions that can be offered from our side, and we would say it's better to use the pre-made, pre-packed grout system. So these are some of our product solutions. This Purostop FSL, like this is the tough elastic structural sealing. That means this has got a very high compressive strength as well. The epoxy-based systems, of course, they go much more than 90 MPa in strength, so it's not a problem and can be easily used for most kind of to address most type of cracks in the structures. Just a couple of quick videos to for you to have a look as to how we do the microfine the cement injection, and the one that follows will also be on both the epoxy system as well as for the PU system. So normally, say anytime you have cracks or even like voids inside your structure, that kind of void basically starts creating problem in the load distribution in your element. In that case, you have to make the drill holes along the crack face. Make sure you're intersecting the crack. You normally cover up the crack. I mean, just for the graphic representation here, they're not covering up the crack face. And then you pump in your material. So now this material should be capable of filling in those voids pretty easily, which is why that graphic that I showed you as to how to select the materials. So your material selection depends on your crack width. Okay, so based on that, again, cement and RCC, they are the most compatible materials. So you can pretty much use it for most, I would say, most typical RCC structures where you don't need very high strengths to be transferred. So this is one option of doing it. For most times, what would be useful, or because the load transfer across the cracks needs to be higher, and maybe say if the crack size are really small, then for 9 cases out of 10, what would solve your problem would be a low viscosity epoxy injection. Like this would help you to both fill in the voids, create a homogeneous RCC in that place, and then enable smooth load transfer across your crack face. So the procedure more or less remains similar. You just drill across your element and you intersect the crack, clean it out, attach your packers, and then continue with the injection system. That's it. So the process remains very basic. Of course, we can help you out with different kind of drawings and different method statements as and when they need be. And the same thing kind of goes for PU injections as well. So I will just skip that pretty fast. And then so this is also, crack injection is also seen as one form of strengthening because it improves your load distribution and load distribution across your element. So your elements are basically able to carry much more or carry the same amount of load that they were initially designed to do. Then some of the other forms of strengthening, which again comes on the basis of EN1504, is using CFRP as reinforcement. So you can have like this kind of a system whereby you are putting the CFRP plate into a slot. Like you just cut the slots into your element and you can put the plate on, and then it is filled with an epoxy mortar. You have seen this kind of things, CFRP wrapping, carbon fiber wrapping along the thing. So I'm not getting much into these technologies because again, it's too big of a topic to kind of include in our overview. And say in case there are certain buildings, like if you're talking about inside of buildings where fire might be a problem or heritage structures, so there you can't use epoxy. So in that case, where we come to is the fiber reinforced cementitious matrix. So what happens here is that it's the same carbon fiber mesh, but rather than being encased in epoxy, it is encased in a uh, it's encased in a tough but flexible cementitious mortar. So that also opens up a lot more application ideas, especially where fire resistance is involved. It gives you the same strengthening as CFRP, but at the same time is much more easier to handle and much more easier to apply. So again, taking a look, just going through our um, list of repair procedures. The first one comes into surface preparation. Of course, a lot of different methods are available, basic chiseling to shot blasting, using these needle guns, using a good grinder. Like oftentimes we kind of forget the importance of using a grinder to do our surface preparation work. But one of the best ones that comes through is the high pressure water blasting. So what that allows us is to remove the top entire latents and all the other problems without doing much damage to the structure below. It doesn't open up micro cracks. All these other methods are a bit more harsh, and they might open micro cracks into a substrate, which might create problems later. So this, of course, remains the best way of high pressure water jetting remains the best way of preparing your concrete or steel as well. So now, the degree of preparation, there are certain guidelines given by ICRI. So based on the type of treatment that we want to do, whether we are looking at concrete overlays or polymer overlays or self-leveling toppings, then what it does is it describes a CSP. A CSP is a concrete surface profile. So it says that your CSP1 is like this level of smoothness, and CSP10 is like kind of a rough finish surface. So this is one of the documents that if you just search it online, you'll get it, and it's a good guideline as to how to prepare, or to what degree you should prepare your substrate. The same goes for steel. In most cases, most coatings will say that you clean the steel to class 2.5, which is kind of a really clean finish by removing all the rust. Now, even EN1504 actually makes a pretty clear recommendation, saying that chemical ways of removing rust, that means rust removers, are not recommended because they can create. See, any rust remover is basically maybe it's pH neutral, but it is acidic in nature, and that might at later stages in time might affect your concrete performance or repair performance. So rust removal should be only primarily by mechanical means, and that's what works best. So once we have got the substrate basically prepared, we go for the next step, that is corrosion protection. And when we talk of corrosion protection, the best thing or the most easiest thing we can do is use an active coating for the reinforcement. So these are mostly mineral-based materials. Okay, they contain OPC and other active electrochemically active pigments, and these pigments and ingredients act as inhibitors, providing a localized cathodic protection. So it looks like this. You just mix a powder with water and you just apply it onto your prepared steel substrate. For example, the product that we have is called SS Anti-Carbonation. It's very easy to use. Can be used in almost, I would say, 9 times out of 10 for all your concrete repair strategies. The next one is your barrier coating. So these are basically resin-based coatings like zinc-rich epoxy systems. I would say use them a little bit carefully, because then there is always problem of subsequent bond, and you don't really need one unless you're looking at, say, maybe marine repair or very quick repairs, or something like that. So use it a bit sparingly is my recommendation. So once you do your substrate preparation, you do your corrosion protection, then you look at the bond coat. So bond coat is nothing, it's simply just making a bridge between your existing substrate and your mortar to be applied. So in our case, the same material, the SS anti-corrosion, that functions as a corrosion protection, the same thing also functions as a bond coat. So you can just mix up the same material, apply it onto your concrete substrate, and then apply the mortar fresh and fresh with that. In case epoxy is needed for, say, things like floors or somewhere a higher bond might be needed, and we also do have other epoxy-based systems available for that. But again, the first thing, always keep for concrete repair, it's better to use cement-based materials. So cement to cement, the performance and the compatibility is much better. Then comes your concrete replacement system. So these are basically what we call your polymer modified mortars. We recommend that the mortars are all that you better use a ready to use mortar, because again, getting today sand, getting cement, and then using a polymer, mixing it on site, it becomes too much of a kind of a hassle to get together all these different things together on site. So it is recommended to use pre-bagged polymer mortars. You can now get it both as a trowel applied grade, and you can also get the same thing as a spray applied grade. So it's very easy. Just simply you have a mortar spraying machine. You can do large areas at in a go. So based on international standards on EN 1504, if you're looking at structural repair, then very simply what you need is a compressive strength, more than 25 or more than 45. So this is category R4 or R3, and plus they also have some durability requirements. So they're very clear again what mortars can be used for what particular purposes. So again, your mortar compressive strength should be matched very closely to your substrate. So it should not be like if you have a substrate that's M30 or M35, then you're using a mortar which is like, say, M70 or M80. It's not required. It should be matched pretty closely to your basic substrate. Micro concrete is another area which you can do. So even if you can just do your corrosion protection. If you have a large fill material, just put on the form and then simply pour in your concrete. It's more or less like a pour and fill. That's it. So micro concretes, again, very simple to use, but they're governed by the same codal provisions as the first one. So when we take a look at what do we need, like basically our mortars should have low shrinkage, high tensile strength, enough flexibility, as well as strong bonds to the substrate. And also what you're looking for in fresh mortar is your reduced water demand, then quick and complete drying, reduction of rebound if you're using spray mortars, and again, good bond strengths. So that means you should be able to work with it very easily on the structure, and at the same time, it should give you the required mechanical protection as well. So these are based on EN 1504. These are the basics that you need. This was the compressive strength requirement I was talking about. Then your adhesion strengths that I was talking about. You also have capillary absorption. It should be pretty low, and then based on your system, you can design it for carbonation resistant. Then you can have controlled shrinkage and expansion, thermal compatibility. So a lot more durability requirements can be built into your mortars, and the type of mortars will then that you select will kind of depend on your end use. So again, ask us more. Of course, curing is important. So ask us that which grade of mortar or what micro concrete is suitable for what particular purpose, and based on your particular site requirements, we can make the proper recommendations. Another area that we have is your heritage mortars. So heritage mortars, that means old buildings. They don't really like use of cement because cement makes the whole structure very rigid. So what you need basically are OPC free mortars. So these don't contain any cement. They're based on lime. These kind of mortars can be traveled very easily. You can just see they're very easy to work with. So you basically need them to match the properties of the old building. Like this is also one more demo which shows you what is the kind of bond strength that you can see. So basically, it was this mortar was kind of applied onto two bricks, and simply those bricks are put together, and then you can simply see that they very easily, I mean, it's a very kind of tacky kind of material. It will stick well, so you can use it for old pointing, old plaster, restoration of certain, if there are certain broken pieces, then you can very easily use this mortar to kind of fill in those broken pieces. So it's an additional kind of mortar that you can use, but only for old structures. Okay, you can see it's got very good bonding strength, so it will bond to pretty much any old substrate. So again, from our side, lot of options are there. You've got your basic troweled mortar. Your SP stands for the sprayable mortars. A high strength mortar. Your free flow non shrink micro concrete is there, and then of course Historep is your heritage mortar that we got. So after you do that, the next part is also doing cosmetic repairs just to ensure that you get a smooth substrate. Because in case your substrate, or say in case your substrate has got these pinholes or problems like that, and if you do the coating on top, whenever there is a lot of heat, the coating will just tend to bubble. So which is why filling of the bug holes is very important, and you need a proper cosmetic repair to do this kind of things. And in case there are again surface imperfections, it won't work. So you need to have a travelable mortar that can work very easily, and you can fill all the pinholes so that you have an absolutely plain, smooth surface like this for your coating. So your protective coating system will also perform better. So now we get to that part of the presentation whereby this is almost the last segment, that is protective coatings. And surface protection systems are basically one of the most important steps. Of course, you can do them on new structures as well, but they are definitely a need after a structure has undergone repair and rehabilitation. So what they basically do is they work with things like reduction of water absorption. They protect against the ingress of waterborne pollutants like chlorides or sulfates or things like that. What they basically do is they increase the concrete cover. That means in terms of durability, maybe say 300 microns of a particular coating might be equivalent to almost about 70 to 80 centimeters of concrete, or like M30 concrete. So it gives you a very high degree of protection. Now, surface protection systems, we can break it into different product groups. Like there are three basic product groups based on the EN criteria. The first one is your hydrophobic agents, and these are based on simple silane, siloxane, silicone based polymers. So you apply them, and they kind of go about 4, 5, 6 mm into your concrete substrate and kind of hydrophobize it. So that's why they're mostly called hydrophobic agents. Then you have your impregnation and primers, which kind of leave a very thin film. They impregnate into your concrete but leave a very thin film on the substrate. So they also act mostly as what we call primers. So these are basically pure resins. That means pure acrylics, pure PUs, pure epoxies. Then they act as your impregnation primers. And finally, you have the coating systems, which can be based on cement, epoxies, polyurethanes, acrylics, but they're all basically filled systems. That means it will be these pure resins along with fillers, so you can have a coating and it kind of protects your structure in the long run. So your basic silane siloxane system, it's a hydrophobic agent. So as soon as you apply it, it kind of just comes down through your concrete, enters it and protects it against the ingress of water. Very simple mechanism. Your impregnating agents or your primers, they very simply leave, like I said, they very simply leave a small, barely thin coating on top, and it kind of covers all the surface discontinuities. And on top of this, you can put any coating that you choose. And what a coating normally does is it really provides you protection for your concrete. So that means it fills in all the surface imperfections, and on top of that leaves an additional layer, which kind of acts as your protection for the concrete system in general. So surface protection is needed. You need to have optimum protection against aggressive media, and it has got long-term benefits. For example, if you can see Rekha, then she has been like this for quite a long time, and especially because of the kind of surface protection she uses, a lot of facial creams, masks, and so on. Because if that was not there, it would probably lead to fast developing aging, and she would probably look like this. So, which is why we say that protection against aggressive media is very, very important. And a lot of times when we talk about things like anti-carbonation coatings or even polyurethanes or things like that, people feel that they are paints. But something you have to understand that these kind of coatings they protect your structure against a lot of ingresses, and they are not basically paints. Good protective coating will have like all these different properties put into one. Things like chloride and carbonation resistance, then water vapor diffusion. It should be open to water vapor diffusion, but at the same time should be waterproof. That means it should not let water inside. Pretty much like your human skin. It should have crack bridging abilities, and of course, if you're applying it in the open, then it should be resistant to UV and weathering. Say a lot of times the problem comes in selecting the wrong material for the wrong application. For example, if you're looking at basements, underground systems, so there one can use things like polyurethanes. But once you're taking a look at protecting external structures like external facades of buildings, bridges, tanks, any external vertical surfaces, for example, there what you would need is a breathable acrylic coating. Otherwise, you mostly see problems like this kind of osmotic problems that come in. So, talking a little bit about the requirements, what you need is basically one of the first things is chloride and carbonation resistance. So, this is basically tested by testing the carbon dioxide as well as chloride diffusion through your concrete. So there are limits to it based on the IRC SP80. That is the one of the few Indian codes that you have on repairs. Of course, it's for bridges, but again can be used for quite a lot of different things. And also it is tested for salt spray, for example. So this will give you, like, if you want to use the same coating in and around marine conditions, it should be able to withstand those kind of things. So salt spray test is also important. The next requirement, of course, it should be resistant to UV and weathering. And normally, how this is tested is by ASTM G53, which tests like the coating is kept under a UV light for say about 400 hours to almost about 2000 hours, and then they see what is the effect of it on the coating. Of course, your coating has to be resistant to water ingress. So basically, it's tested for water permeability in accordance with EN 1062. So that should be very, very low. That means it has to be less than 0.1. If not, your coating is going to let water go through. The next one is a little bit antithetical or opposite to what we saw in the last slide, and this is that the coating should be open to water vapor diffusion. That means it should allow water moisture from the inside to go outside, but it should not allow water from outside to come inside. And this concept is basically called as breathability. So breathability and water repellency, they're kind of part of the same coin. So how we design it means, to put it very simplistically, as I'm a Goan, I like fish. So the coatings are basically designed as the net over here. Okay. So when we talk about water vapor, then water vapor is pretty much, there are these small fishes, very small in size, water vapor molecules. But your basic water molecules or your carbon dioxide, SO2 chlorides are bigger molecules, so they cannot get through the net. So it's very simply that if we can design the opening size of this net properly, which we do with anti-carbonation coatings, then we do get a pretty good breathable coating. The next requirement, of course, is also since this is used on a lot of dynamic structures like bridges, or it is used even in tall buildings under wind loads. So that means your structure has got some kind of movements, it's got some kind of dynamics. So it does need a crack bridging ability, and that is what is also tested. So one of the solutions that we have here, and which is has been used again for quite some time now, is called SS Protecticon AC. It kind of has all those 4 5 properties that we talk about for a good protection system. I'll just show you the next this one. I'll just show you many examples of where this kind of things has been used. For example, it is you can use it for very different kind of bridges, structures like that, and this coating has been basically tested and also approved in line with IRCSP80, that is guidelines for that is by the Indian Roads Congress, and also by the specification for roads and bridges by the Ministry of Road Transport and Highways. So these are two of the guiding specifications that talk about these anti-carbonation coating, and EN 1504, of course. And a material like Protectocon AC actually meets these kind of requirements with extensive testing done both at IIT and at other locations. Of course, we can provide you all these details when we talk more about it, but now it's much more to understand the concept as well. So this kind of materials that were pretty easy to use. That means it's simply a primer system, and then you apply it. Then you apply the first coat and the second coat. So application can be pretty easy. I mean, don't we should not take such unsafe application techniques into consideration. That means we need to use say proper safety equipment, proper spray material methods, proper scaffolding, proper safety gear for the people who are spraying, and so on. And you can actually see that using these kind of systems, the jobs can be done very nicely, very easily, and very quickly too. The application for this kind of material is manifold. That means you can use it for structures like bridges. Uh, you talk about cooling towers and chimneys. You can use it for those. Concrete silos, storage tanks. Again, these are just some photos of different bridges. Walkways, bridges in marine conditions, bridges across culverts, across rivers, even kind of different culvert structures you can very easily do with this kind of a material, viaducts, high structures, and even coming to buildings. So you first do the cosmetic repair, with the fine mortar, kind of give it an even surface, fill in all the cracks and everything, and then go with the coating on top. This is just a few examples of where we have done it for an entire hotel complex. So they were having a lot of problems with waterproofing, and this kind of material also solves those waterproofing problems in general. It's for a large resort in Goa. Again, different lot of buildings have been done with this, houses, factories, especially in industrial zones, in inside of parking structures. This kind of material has got lots and lots of application just as a protective material inside parking garages, in industrial zones, to put any kind of concrete structure. The bridge that we have done in Kerala. So again, you can see all different type of infrastructures, all different types of colors, all different kind of exposure conditions has been taken care of with this. Even we have even used this for heritage structures because of its flexibility, because of its breathability, and since it allows water vapor transport here and there, you can very easily use it on old masonry structures, where you actually see a lot of moisture transport. This is a church that we have done in Goa, as well as temples. So lot of options are there. So if you are using the Historep mortar for restoration, we can also use this protective system to protect it in the long run. So when we talk about the concept of protection, we say it is better to leave concrete unprotected rather than protecting it with non-breathable coating. So you have to select your coating based on the kind of application that you're looking for. If it's structures above the ground, in most repair strategies, it has to be a good anti-carbonation coating. If you're looking at basements or somewhere inside, of course, you can look at other waterproofing based systems, PU based systems, epoxies, and so on and so forth. So ask us how we'll do that, because it's the right teamwork of technique, materials, machinery, and manpower that will actually make your repair project a success. So anytime you come up with a question on repairs, or anytime you have an issue with selecting these materials, that is what exactly we are there to help you out with. So in conclusion, protect your concrete and your steel will take care of itself. And using the systems that we all had, we can pretty much take care of any repair problem in and across the construction domain. So as like last time, I would say stay safe. These are the times in which a pandemic is going around. So stay indoors, contain the spread, help flatten the curve, use masks, wash your hands, practice social distancing, and just stay indoors and stay safe. Okay. So the next, a quick announcement I'd like to make is that the next presentation would be on waterproofing and soil stabilization using modern injection systems. So this would kind of highlight the applications of a lot of the product system made by TPH, our exclusive partners in this line. So they have a lot of experience looking at the properties of the materials and looking at different kind of scenarios in which which these materials can help out your next construction project. So definitely join us. Look out for our invitation in this coming week, and we look forward to seeing you pretty soon with this particular session. And with that, I would say these are the email IDs you can always get in touch with us from. So SS, you can get in touch with us on our website as well, and also as on our email address. So write to us in case of any questions. Um, Write to us in case of any questions and any comments, any ways we can make this better. And we are here to help support you. So I think with that, what we'll do is I'll just kind of put my screen share down. So we should be able to also, just 1 minute, I'll just stop my screen. Okay. So now I do have now I can put this on the main, I can put this on the main screen. So now we can also, what we can do is get together with some questions. So let me just, I do have a list of it here on my phone. So, uh, one of the first question is from Mr. Basavraj from Bangalore, and the question is that we have had bad experiences with injection grouting. What is the best material beyond PU and epoxy? I would actually I would take this question in a slightly different way. Is that I would say it is not that the material that is bad, but I think something has probably gone wrong in the selection of the material. So, for example, if we say that if you want to treat a crack for say structural purposes, then I would say epoxy becomes the better material because it can actually transfer loads across the crack very effectively. If you're talking about waterproofing, then I would say PU works much better. If you're talking about waterproofing and you need a very flexible sealing, that means your cracks are actually moving continuously and you need very flexible sealing, then in that case what you have to do would be say maybe use an acrylic gel in that case, because these things are very flexible. So once you fill in the crack with an acrylic gel, it will give you a lot of movement capability. So in case even the joint tries to or your crack tries to open up, you can then maybe say it will kind of prevent it from opening up further. So I would say it is not which material is bad, but the question is always that is it the right material for the right application? And I think that is where we come in. That is where we can help you to make the selection by evaluating your particular site conditions. Will make you a recommendation saying, this one works good, or the second one works good, or the third one works good. There cannot be one solution or one one material for each and every problem. Okay, moving on to the next one. How to The question that I'm seeing here is um, how to I would say treat non-visible cracks or honeycomb in main members. How to assume the gaps are filled and to know concrete achieved the required strength. So again here there is two particular there are two particular things you can do. So this comes more out of the experience in working with the injection system. So say in case you're doing injection grouting, so you do have your say for example if you're looking at a column for example. So in that case you start the injection from the lower part, and until you see the material come out from the next grout hole, that you know that that area is filled. So something as simple as that. The same can go for epoxy as well. So in case you have your surface sealed completely, and you don't see any backflow, maybe because of a low pressure or something like that. So after, say, maybe after some time, you can even do something just to test the efficiency of your injection methodology. You can even test it by removing a core from one of the places. So in case you see all the cracks filled and all the cracks filled satisfactorily, you know that the kind of methodology they're using is absolutely correct. As far as that, once you do the epoxy injections, of course, you can put, say, maybe if it needs patching with a polymer mortar, you can do that, and then a protective coating on top would be one of the best things you can do. Okay. And the next question that come up is, yeah, the next question that we have is again an interesting one. So that goes a little bit more towards I would say our consultant friends. How to find that the steel is rusted in the RCC members, and what are the methods available? Well, the first, and there will be some indications, like things like you might see some rust spots around your RCC element. In other cases, you might find cracks running parallel. For example, if you have a beam, then you'll find the cracks running, say, somewhere at the bottom, or you'll see the shear cracks running. So that is normally an indication that there is, that means that means your reinforcement is kind of expanding and is starting to create the cracks in the particular element. So in case you have these kind of a doubt, so after that, there are a lot of testing available, like non-destructive tests available for it. You can do something like a half cell potentiometer. I think most testing houses and testing agencies in your local region should be able to help you out with these methods to find out whether corrosion has progressed. Okay. There's another. Okay, there is one question by Mr. Kamaran, and the question that he has put out, two quick questions. The first one is, can you throw some light on tests that can be conducted on such repairs that addresses and satisfies the durability requirement of the structure? That is the first question. And secondly, warranty you could provide for such repair structures locally and wholesale. So say I would say take the first question, the first part of the question is the testing that can be conducted on such repairs and that addresses and satisfies the durability requirement. So say here when we're designing the repair system as a whole, so it will be a combination of everything: the substrate preparation, the materials, the execution, and the finishing part of it, the final protection and everything. So once we are taking that into account, the same test methods that we do for the initial diagnosis, that means things like, for example, if you want to test for voids, UPV would be the best thing to do. If you want to test for surface strength, the Schmidt's hammer would be the best test to do. If you're testing at the efficiency of your reinforcement, the corrosion potential, then a half cell potentiometer would be the best test to do. If you're testing whether your coating that has been specified is applied properly, so in that case, you can always test whether the coating thickness has been done to a particular extent and so on. So there are the same basic indicators that use in the diagnosis part of it, and I would say in the post part of it, then I think that would be quite an helpful thing. And if I'm right, I can see Mr. Kamaran on the screen. So I'll just unmute you for a second here. And sir, did that answer your question?
Yes, it is. But UPV test which you are recommending, is that reliable enough for us to ascertain whether it satisfies the durability requirement when you have an expected design life of a structure to be 120 years? Plus,
So UPV is an indication, but say in case, say I used to work in the testing industry when I was in the US. Like I used to actually work for a material consultancy services. So basically, what we used to do that the UPV is only an indicator. So you do it across a big grid, and you can do it very fast. So you do it across the core, and say in case we see 3 or 4 problem areas, then in that case maybe say we go for a coring of the particular we will take a core out of the affected area, evaluate that, and then base the repair strategy based on what we see out of that information from that core. So in terms of say compressive strengths, or whether say also we used to do it very frequently for doing piles, for example. We used to do the pile foundations, and oftentimes there are big voids and everything which need to be grouted later on. So mostly what used to be done in the first step, it used to be a cement grout. So once the cement grouting is done, and we used to have this cross hole sonic system. So
yes.
that was basically the UP that can go down. I mean, the concept is similar. So we used to once the first grouting is done, we used to once again run the test and see if the problem is still seen, do a second round of grouting, maybe with an epoxy, because this time your voids are going to be much smaller. Do that, and in case there is still a problem, then we resort to the coring, rather than saying that an element has failed, or something is not there. I think it is to be taken up in a step by step manner. That is my thought process on this. Then, as far as the warranty to be provided for a repaired structure, I think that is something that is more of a requirement that needs to be worked out between the different parties involved. Because I think, despite being the kind of good engineers, and really intelligent engineers that we are, I don't think anyone can make a promise like that, saying, okay, no, this repair system is done and it's 100% going to work. Because if the structure was designed like that in the first place, we would not have a repair in the first place. But normally, when things like that happen, always a what we call a reasonable agreement can be come to, because that is something to do more with the contractual situation. So maybe something like a maintenance plan or a maintenance program or something like that can be very easily put together.
Thank you very much, Mr. Sani, for the
Okay,
clarification.
thank you, sir. I'll just see if there are any more questions. Then there is one question. There is one question which we have is there is one. Okay. Okay, so here's another question from Engineer Dr. Abhay Gupta from Noida. We've used micro concrete with 30% aggregates for structural retrofitting of columns, and we have observed random cracks on the surface after 10 days to 30 days on the surface in almost all columns. Please advise on correct usage in concrete jacketing. Okay, so this is another one area. So here I would say it's a little bit difficult to kind of do the diagnosis on basis of a question. But a few things that instantaneously pop into mind, like some of the probable causes. One would be simply shrinkage in the microconcrete. I mean, if the microconcrete was not designed properly, or it was not mixed and placed properly, then in some cases it would have a shrinkage to do it. Or if the confinement was not proper, for example, then that might be one of the problems. In another issue that comes up and that might have happened would be that, say, normally if you're doing any sort of jacketing, then you first have to take the load off the structure first. Okay, so that means you will need proper bracing below the beam, and things like that, so that the loads on the structure is taken off. You fill up the jacketing, and once it has reached a particular strength, you put it back on. Maybe something like that has happened again. I can't say I was too good in structures, scraped by with a few scraped by just missing a few 80 kts in the process. But maybe a structural engineer would be able to help throw out a little bit more better advice as to what's causing the cracking. But the cracking would be because of some kind of an odd loading, I would say. So that is something that you need to see, whether something in the work process, or whether something in the something in the work process or the material process might have gone wrong, and it needs to be traced. The next one is uh, I would just like to know about the hydrophobic product. If the hydrophobic chemical used with intermixing of concrete, then does it impact with concrete strength? Because water cannot penetrate inside of concrete. No, actually, this particular material that I talked about uh, are all post-treatment systems. That means they're used as concrete protection. I mean, once you place the concrete, then you're putting your hydrophobic treatment on top of it. So you get this both in a liquid form as well as in some cases also in a cream form. So you simply just brush it onto your substrate, and it kind of makes the surface hydrophobic. So it's got actually no impact on the concrete strength as a whole. Uh, do we have such epoxy which we can use in drinking water or food items storage structure repair, like water reservoir and water tunnel as well as food storage tank? Is there any certification issued from so and so? Yes, actually, things like this can be recommended. Of course, what I'll kind of re-say what I said before. It is, if you're looking at concrete repair, and if the loads or the chemical loads are not very high, then it is always better to repair concrete with cement-based materials. It's just that the compatibility of these materials is very close to each other. So even your repair mortars or your basic repair mortars or your bonding coats or your corrosion protection coats can all be based on cement, so that you have a homogeneous system to repair it. As far as the protective system goes through, of course there are epoxies available with food grade certification. But we also, in case the chemical loads are a little bit higher, we also do have a mineral based coating system. Okay, so this is something like a material that you apply, maybe say 5 to 6 in thickness. It's a mineral mortar. That means it looks and feels like a regular polymer modified mortar, but it can take pH down to almost 3. That means it can sustain in highly acidic environments as well. Basic is of course not a problem, but it can sustain in very low pH environments, like in a highly acidic environment. So this kind of solutions are of course available with us. The material is called tri-Silcoat. Anyways, you let us know uh, what a particular, or I would say site specific issue is, and we'll be glad to help you out with it. Okay. There was one which says what is the best, what kind of coatings are best suited for structures to marine environments. So again, things like foundations, you can maybe go with a polyurethane or with a pitch modified epoxy system. That is one thing you can do for your foundations. And as far as the rest of the structure goes, you can use our anti-carbonation coating system. It has been there. It has been in use for quite some it has been in use for quite some time. So it has proved itself in practice over lots of bridges, lot of buildings in Goa as well. So that is something you can use. Okay, there is one more question that we have out here. Is there are a few photos shared, and what it shows is actually like a highly cracked beam system. I don't know whether something like this can be seen, but it's a highly I would say it's a highly cracked beam system. So again, I would say this question is by Mr. Sandeep Chaudhary, and I would just say here the repair procedure for this would almost remain same like what we talked about. So that is not going to be very different. Like, you have to kind of think about repairing this with an injection system, followed by a say concrete replacement, and then your protection system. But now the question always remains as to what is causing these cracks. Means, is it simply because of self weight? Is it because of creep? I think that's where a structural consultant would be able to help you out in the right way. So the structural consultant can actually determine that what went wrong and where is the load and what is causing the kind of cracking. The solution, of course, remains more or less similar. So that is something you have to understand, that as to the solutions will remain the same, but you have to know where to exactly do what solution. Means, does this need simple injection grouting? Will that solve the problem, or will it need some kind of bracing? Will it need retrofitting with CFRP? Things like that. So that is where your structural engineer can really help you out with doing this right. Another, I would say, another recommendation I got out. It says, yeah, there are. It says that there are. It's actually a suggestion, much more than a question, and I would actually agree. This is by Mr. Barry Jackson, and what he says is that there are a lot of cases, even in case of structural repair, where say companies like ours who are dealing with construction chemicals are called just to say whether can this work. So I would say you have to again break this down into two things. The first thing is whether your consultant says, is there a structural problem or it's simply a durability problem. If it's a durability problem, yes, we can simply recommend you the right injection system and you can do it. If it's a structural problems, we need to take other precautions as given by the structural engineer. But yes, it does need a specialist from our side to visit your site. We can also assist you with this, but you have to remember that anything to do with the structural repairs of a concrete element has to be done in conjunction with both the people. That means your repair consult. That means your structural consultant, your material manufacturer, and your material manufacturer as well as the applicator have to work together to decide on the methodology as well as this thing. It cannot be a unilateral decision from either of the three parties to solve that problem. So I think that pretty much does it with questions on this side. So yeah, I think that's about it. Let's see. We do have a few raised hands out here. Maybe we can take another maybe 3-4 minutes. Thank you very much. Mr. Mukund Apte is giving me a thumbs up. Thank you very much, sir, for that. And maybe we can just take one or two more questions, and kind of call it a day for today. Of course you can uh, always get back in touch with us and try to figure it out. Just let me see. Uh, just 1 minute, Mr. I think Mr. Mukund is trying to ask me a quick question, so I'll just unmute him for a while. Yes, and now can you hear us?
Yes, I can hear you. Can
Yes,
you
sir, go
hear
ahead.
me? So what I want to ask, when you carry out some piles and in the piling work,
Yeah.
you do,
Mhm.
and if NDT, non-destructive testing shows that the concrete in the piles is not to the satisfactory,
Mhm.
then what is the method you can suggest so that the grouting or any other method can be done for the piles by which the strength can be again achieved by the pile, and is there any particular method which has been adopted and executed by you, which afterwards again another NDT carried out on the same pile shows that the concrete has increased in the strength and the pile is now satisfactory.
Okay. So I would say that is possible, because your concrete depends on the kind of concrete used. Because if it's a concrete designed with a lot of SCMs, in case sometimes it doesn't get its strength on 28 days, you can always look forward and do one on 56 days as well, because the strength increase is quite big. But the as far as the repair part of it goes, like if you're asking me, okay, if the compressive strengths are low, and how do we repair something like this, then I would say that becomes a little bit difficult kind of a question. Let me just see if I can quickly see Mr. Gyot's online, because he's from TPH. He's the owner of TPH, and he has done a lot of work under a lot of varied conditions. Let's see, maybe if we have him online.
No, I
Maybe
will add something in it,
yeah.
if you won't mind.
No, I don't. At least I don't. Oh yes, I just see him. So okay, I'll just unmute him. I'll just unmute him here. Ask to start.
Hello, Sunny.
Yeah, hello girls.
Hello,
How
hello.
are
How are
you?
you?
Yeah, girls. Actually, there was a question I was hoping you can help me out with.
I
Uh,
try to do this. Yes,
yeah. So he said, is there any method whereby if the piles are already casted and it was found that the strengths are lower in the concrete itself, then is there any way to repair this kind of a scenario?
difficult. Not quite easy. I think. Of course, you can do some drillings into the piles and try to find the holes, hollows, cracks inside, and to inject them. This is the way we do, as you know, we do in grouting injection. We try to find the hollows and the honeycombs in the structure and try to fill them with a rigid or more elastic material. But it will be not easy because you cannot see what you're doing. So this is just a try, and may you get it or may you error. Yeah, you never know it. So this will be not very easy to do this, and you have, I think, not a complete documentation about success or not, but it's a try. So if nothing helps anymore, I think this could be the last idea to rescue all the pilots. But I think it's an idea, yeah, but tricky.
I would say that maybe another thing that can be finally done is a load testing part of it. I mean, finally, it's the performance of the pile that matters. So in case if it's working on a load test, then I think that would be something rather than demolish a pile. Maybe that might be the easiest way to find if anything else can work.
Yeah, Sonny, exactly. Yeah, I agree in your idea. So we just finished a project in South Germany, close to Munich. They had a lot of problems with the cement piles. Yeah. There were also many cracks, visible and invisible, in the structure. There was a problem with the cement supplier. They delivered not exactly the right quality, and with that cement they made many piles. And the problem was how to repair them. There was some visible cracks. We repaired with a high strengthening cement injection, the fine injection cement, based on just normal cement, but containing a lot of polymer powder. So the strength is quite close to epoxy, around about 60 to 70 megapascal. So this is really reliable quality. But the problem was more the cracks inside we couldn't see. And what we recommend with our technical team was visiting the site and stayed during this reparation work with the client. And they made some load tests. And during the load test, they identify more and more cracks that was hidden before, and they could repair it. So a load test, I think, in any way, it's a very reliable method to figure out, first, of course, the strength you have for sure, and the cracks. Yeah, you will see more and more with the load.
Yeah, and since I have you on the line, say an earlier question by Mr. Kamaran. So that was he had asked about some. Can you throw some light on tests that can be conducted on repairs that addresses and satisfies the durability requirement? I mean, I know you work with a lot of with the EN codes and with the code generation. Maybe some input from you on this particular topic would really help.
Of course, yeah, thank you. So, of course, what we do, as Sunny you mentioned, we have a lot of long-lasting and durability tests from different institutes in Germany and Europe, as well as institute from outside Germany, US or Canada. But of course, the question is
on the repairs also. Means once we
on the repair, yes, this is more the problem. The tests before in the laboratory are pretty nice, but the question is which performance have my material on site after the application, and what we do in many times when we have a huge maintenance job that we hire a test institute. They will guide us and they will observe us during this work, and they will give us and at the end of the day a complete test report about the work, about the final strength and the final circle lifetime of this building. So I could highly recommend to all of you that for bigger jobs you should hire an institute or an engineering company that observes your work and gives you a paper that means guarantee. So you are a bit out of your guarantee because you have an observing institute that takes over this guarantee by producing a paper. I think this is very reliable for all of the clients and the other engineers.
So that means basically an ongoing third-party testing agreement kind of. So somebody
third-party idea.
Take care of the quality issues during the repair process itself.
Yeah, because then you have an absolutely proper documentation of that, what went on, and of course about the result and about the expected lifetime.
That sounds good. Here we have another one of our old hands from the industry. I'm seeing is Dr. Harshvardhan Subbarao. So maybe can I just have you? I'll just unmute you so that we have you on speaker. Sir, any?
Right, Sunny, I think that was an excellent presentation.
Right, thank you.
Very succinct and bringing in 1504 and bringing in all the new technology you're trying to give us. And yes, working as a team is the only way to deliver a repair rehabilitation project. That it is multidisciplinary. It necessarily needs to be so.
Correct.
What is interesting to note is the development of new materials.
Correct.
And it would be some time before we can develop Indian standards to allow for all those regimes of testing and acceptance criteria. Correct. It would take some time. I can see that. But that's innovation. Innovation's always ahead of any code. So, I mean, we shouldn't be scared to try things out, provided we have a reasonable basis and a reasonable knowledge base.
Engineering judgment, yeah.
And engineering judgment. And we have to take some things into our hand. If the multidisciplinary team works together, I'm sure the products will always be good. On the other hand, we don't in India have anything close to 1504. I mean, the underpinning thing is we don't have a comprehensive repair rehabilitation code.
Right.
Nor do we have anything which gives statements of workmanship rules. We don't have the workmanship rules requirements also enshrined in a system of codes. So maybe that's one direction in the future to go. And the certification, the third-party certification process, we do have many test houses and many companies in India, including DNV. There's so many others who are doing that. Whether they actually will align with all projects and the scale of the project. Everything depends on the scale and cost. So whether they will or not, that also remains to be seen. But wonderful presentation. Thanks.
Thank you, sir. I would say, and maybe, I can see Mr. Kunjan here. He has been one of the guys who has been instrumental in putting this together. So, Kunjan, we have you live. So, anything, your thoughts, your inputs, you have actually done a lot of the repair jobs. Anything practical you'd like to bring to the table?
Nothing much over here, Sunny, but it was a very good presentation. Yes, for all the works we are doing, specifically each work is different. So we should not make a standard pattern for everything. There will be difference in each and every job. So it should be, like we said, an expert should go and specify the job more preferably than anything else. You can't have a standard medicine for each and every disease possible.
Perfect. Thanks, Kunjan. I see Pithaura sir here as well. So any inputs from your end, sir?
Well, Sunny, it was a very good presentation.
Thank you very much, sir.
Most of the points were very clearly mentioned. Okay. Only thing I'll request you one thing, that will you share the presentations of this webinar and the previous one,
yeah,
so that we can have a proper insight into the matter. बात गई हो जाएगा.
No problem. So we are working on how to get that and separate that through. So hopefully in some time. Just give us some time.
Okay. Thank you.
I think that pretty much would do it for today evening. Thank you very much. I know there are a lot of questions still that are unanswered, but please we look forward to having you contact us. If you have a pen and paper, again, my number is. Let me see if I can put it on the screen somehow. The thing is, I'm not very good with this technical things going on here, but no, I at least can't see anything.
Share your card.
I'm not sure how to do that. But okay, in case you have a pen and paper handy, my telephone number is 98-212-88717. And also, of course, at the end of the presentation, I had our email address on. That is this particular one, info@ssbuildchem.com, or you can just log into our website as well. That would give you all the contacts as well. And really, thank you very much. I mean, I know it's been running for quite a while, and thank you for participating very enthusiastically with this. Thank you for giving us your time, and hopefully I could add or we could generate some more ideas for your next upcoming projects. And we look forward to seeing you next week for our next presentation on injection systems. So the invites for that are going to go out shortly, and we'll see you soon in the coming week. Thank you, everyone. Have a nice evening.
Thank you, Sunny. Thank you.
Bye, everyone.
Thank you. Bye-bye.
Bye.